Alright, hello again everyone. So this is going to be our second part of our practice final exam solutions for a little bit of extra credit. So let's get right into it. Question 3. Find the center of the mass of the lamina of uniform density. I don't remember what this is called, so this is going to equal 1 bounded by the graph of f of x equals 4 minus x squared and the x-axis. Alright, we need 3 formulas here. No, 4 technically, so we'll just get right started. So first, let's find our mass. To find our mass, we have this, which is that. So it's just equal to 1. From A to B, while we're here, let's find our limits, our bounds. So 4 minus x squared equals 0. 4 equals x squared plus 2 minus 2 equals x. Bounds are negative 2 to 2. And our mass equation is going to be the following: f of x, right? So 4 minus x squared dx. So more or less we can get rid of the 1 as well. So let's just go ahead and do our integration. 4x minus 1/3 x cubed from negative 2 to 2. So our mass is going to be 4 So 16/3 minus 32/3. Next, about the y-axis. My equals negative 2 to 2 x 4 minus x squared dx. I'm going through these rather quickly because the integrals are rather straightforward. So so 2 4 minus 4 equals 0, which is your my. about the x-axis, which is your mx equals -2 to 2. We have a constant of 1/2, so I'm going to move that out to the front. And then we have 4 minus x squared. Sorry for my coughing. I'm a little bit under the weather, so I apologize, everyone. So when we do the math out here, we're left with 16 minus 8x squared plus x to the 4th. All right, so my apologies, I fat fingered a number. 5. Number 5 minus 128 mx equals 256 over 15. Alright, so now what do we do with all 3 of these? So our center of mass, which is what we're looking for, x bar equals my over m. So we're going to have 0 over 32 over 3, which is 0. Our y bar equals our mx, which is 256 over 15, divided by our mass, which is 32 over 3. And then if we do the math on that, we are left with 8 over 5 as our x bar. So our center of mass is 0, 8 over 5. All right. Question 4. We're going to solve the integral of x to the 5th sine 2x. All right. So for this, to make my life just a little bit easier, I'm going to use the tabular method here, because I will have something that will eventually it will go to 0, which means I won't have to do any sort of integration. All right. So We're going to differentiate on this side. We're going to integrate on this side. It's going to get a little confusing, but alright, we start out with our x to the 5th and our sine of 2x. So let's go ahead and differentiate first. So I'm just going to kind of blow right through these, so I need to give myself some room here because we have a good number of these things. So alright, 5x to the 4th, 20x to the 3rd, 60x squared, 120x, 120, and 0. I'm going to double check myself to make sure I did that correctly because I did it rather quickly. 60, 120, okay, we're good. We're going to alternate plus minus, and to help out with our sign, I'm going to draw my little clock that I have here. So to integrate, we're going to go backwards. Starting out with sine, so we have, keep in mind because we're integrating, we're going to be dividing this whole thing by 2 from here on out, okay? So we have our sine. We have a negative 1/2 cosine of 2x. Negative 1/4 sine of 2x. One-eighth cosine 2x. 1/16 sine 2x. 1/32 minus cosine 2x. And from here we're left with a negative 1/64 sine 2x. Now if we didn't have this x to the 5th cancel out at 0, what we would do is we would actually stop the integration here and then take an integral of that. But since we have something that actually zeroes out, all we have to do from here is take our diagonals keep in mind of all of your all of your addition, subtraction signs, all of that. So we have our x to the 5th sine 2x equals negative 1/2 x to the 5th cosine 2x. A minus, plus a minus is in addition, so plus 5/4 x to the 4th sine 2x. We have two plus signs here, so I'm going to add a plus and I'm going to, so 5/4, 20/8 x to the 3rd cosine 2x. And then we'll come back down here, minus 60/16 sine 2x minus 120/32 x cosine 2x, minus plus minus, get a plus 120/64 sine 2x plus your constant of integration. Now you can simplify a lot of this. To keep things very simple, like really simple, you can simplify this one, this one, this one, and this one. But because this one is so gigantic and large, I'm going to keep it like this, and we are just going to call it a day. Alright, so this is the end of part 2. Stay tuned for part 3. Thank you very much.